Now, in this video lecture, we will summarize in a tabular form that what are the different type of hybridization and what should be the shape of that particular hybridized molecule and what may be the bond angle connected with that hybridization and one or two examples. So that's why I have written a tabular form, type of hybridization. Second is your bond angle. The third is your shape. And the fourth is example. The first type of hybridization is your sp type of hybridization. We pronounce it as sp type or simply called sp hybridization. Now when the sp hybridization we have, then the shape of the molecule is your linear. So if in a molecule, if a particular atom have sp hybridization, then the molecule have a shape linear with a bond angle equal to your 180 degree. And the example, if you consider, it is your beryllium chloride, carbon dioxide, etc., etc. Now, the second example or second type, better to say, it is your sp2. We should not pronounce it sp square. इसको हम लोग sp square नहीं बोलेंगे, इसको हम लोग बोलेंगे sp2. Now if the hybridization is sp2, then the bond angle will be your 120 degree and then the shape will be your trigonal planar. Your shape will be trigonal planar or it is simply called planar. इसी को देखिएगा कहीं कहीं लोग बोलते हैं ट्रायंगुलर प्लानर. सो वेदर यू से ट्राइगोनल प्लानर और यू से triangular planar or you simply write planar, having the same meaning, nothing else. The example is your boron trifluoride, that is BF3, and your BCl3. Now let us discuss in brief. The meaning is, in this sp hybridization, actually in beryllium chloride, we consider the hybridization of beryllium. बेरिलियम क्लोराइड का हाइब्रिडाइजेशन नहीं होता, बेरिलियम क्लोराइड में बेरिलियम का हाइब्रिडाइजेशन होता है और वो हाइब्रिडाइजेशन बेरिलियम का होगा sp. Now what does it mean? It means if you write beryllium you know it is 1s2 2s2. आपको आगे डिटेल बताएंगे, डिस्कस इन डिटेल. As in case of hybridization, only the outermost orbital means orbitals of outermost cell. भाई इसका सबसे बाहरी सेल क्या है? सेकेंड सेल बाहरी है. तो आप तो कहिएगा कि केवल सर 2s है, but along with 2p we will discuss in detail, no doubt we will discuss in detail further. 2s is filled and 2p is vacant, so they will intermix together to give how many hybrid orbitals? 2 hybrid orbitals. Each of them is known as your sp and sp of same energy and same shape. So the shape of this molecule means shape of your beryllium chloride molecule, in which your beryllium has sp hybridization is linear. And similarly, if it is sp2, the bond angle will be your 120, means the hybridized orbitals are at an angle of 120. Here the hybridized orbitals, they are at an angle of 180. Example is your BF3 and BCl3. The third is your sp3. Here it is your 109 degree, 28 minutes, and the shape is very much clear. It is your tetrahedral. Example is your CH4 or you can say CCl4. One more example in this case you can write, it is your BH3, that is boron hydride. Now these are the only three hybridization which involve S and P orbital. So ultimately we can write there are only three different type of hybridization which involve the intermixing of S and P ऑर्बिटल्स। इसका यह मतलब नहीं हुआ कि और कोई टाइप नहीं होगा, इसका यह मतलब हुआ कि बाय यूजिंग एस एंड पी ऑर्बिटल्स वी हैव ओनली 4 different type of hybrid, we have only 3 different type of hybridization. They are your sp, sp2 and sp3. Now we have to involve d orbitals. So next type is your sp3d. It is your sp3d. Now in sp3d we have one s orbital, we have 3p orbital and we have 1d orbital. 1d कहने का मतलब out of 5d, you know there are 5d orbitals. 1d it doesn't mean this type of 1d. ऐसा नहीं सोचोगे means in this case n is 1 and l is 2. No, it is not possible. 1d means out of 5d, that is dxy, dyz, dxz, dx square, y square और dz square, उसमें से कोई एक, ठीक है ना? So there should not be any confusion. Now if the hybridization is sp3, then the shape will be on, in short we write TDP. The full form is your trigonal bipyramidal. It is your trigonal bipyramidal, और भी में राइट है ट्राइंगुलर बाइपिरामिडल. आप ट्राइगोनल बाइपिरामिडल बोलिए या आप इसी को ट्राइंगुलर बाइपिरामिडल बोलिए, both have the same meaning. Example is your PCl5 or you can say PF5, phosphorus pentachloride or phosphorus pentafluoride. Now in this case we have 2 different type of bond angle. समझ रहे? In case of your sp3d we have 5 bond and they are not at equal angle. It have 3 bond is at 120 degree while the rest 2 is your 90 degree. The 3 bond angle is your 120 and the rest 2 is your 90 degree. So the shape is your trigonal bipyramidal, or we can say triangular bipyramidal. The next hybridization is if you involve one more d orbital. आपने एक d इन्वॉल्व किया है, अब आप एक और d इन्वॉल्व कर लीजिए, तो खुद समझ सकते हैं कि उसका नाम क्या होगा. So the next type is your sp3d2. It is not sp3d square, but it is pronounced as sp3d2. Now in this case the geometry is your octahedral. The shape is your octahedral. The example is your SF6, that is sulfur hexafluoride, and each bond angle, all the 6 bond angles in this case are equal, and that is your 90 degree. Now why we say 6? sp3d में हमने कहा था 5. Why? Because if you consider sp3d hybridization से पहले 1s, okay, 3p, and then we can say one of the d orbital, they intermix together. Before hybridization प्योर एटॉमिक ऑर्बिटल कितने थे? तो प्योर एटॉमिक ऑर्बिटल 5 थे. एक s था, 3p था और एक d था. When they hybridize together, when they mix together, when they overlap together, then they will form your 5 sp3d hybrid orbital. They form your 5 sp3d hybrid orbital. Or you can say they form 5 hybrid orbital, or you can say they form 5 hybrid orbital in which each of them is referred as sp3d, sp3d, sp3d. Similarly, in this case, in sp3d2, similarly we can say in case of your sp3d2, there are 6 pure atomic orbitals. 1s, 3p, and out of 5, 2d. So they will form your 6 hybrid orbital. Each of 6, उस 6 में से each and every hybrid orbitals का जो नाम होगा, that will be sp3d2, sp3d2, sp3d2 with equivalent energy and identical shape. Bond angle we say 90 degree. And the last one is your sp3d3. Last one is your sp3d3. The geometry is your pentagonal bipyramidal. The geometry is your pentagonal bipyramidal. Example is your IF7, that is your iodine heptafluoride. You know this SF6, this IF7 आप पढ़ चुके हो. They have your superoctet. They have your superoctet. I hope you know what is superoctet or what are electron deficient compounds. Now in this case again we have 2 different type of bond angle. 5 is of your 72 degree and 2 is of your 90 degree. So again in this pentagonal bipyramidal we have different type of bond angle. 5 is of 72 degree and 2 is of 90 degree. So this is a simple table of hybridization. Now, there is a shortcut rule, or you can say shortcut method may not be discussed in different book. हो सकता है हम जो रूल आपको बता रहे हैं वो हर बुक में ना हो, बुक में दूसरे ढंग से बताया गया हो. It may be possible, but there is a shortcut way, there is a shortcut method that how we can calculate the hybridization of an atom present in a molecule. किसी भी मॉलिक्यूल में अगर किसी एटम का आपको हाइब्रिडाइजेशन पूछ रहा है तो आप उसको कैसे शॉर्टकट में बता दोगे. So let us see the calculation. For example, we have a question. एक दो क्वेश्चन लेकर के करें. A question is calculate the hybridization of number 1 carbon in methane, number 2 beryllium in beryllium fluoride, number 3 phosphorescent PCl3, number 4 phosphorescent PCl5, and number 5 sulfurine SF6. So what should be the hybridization? मान लीजिए इसका आपको हाइब्रिडाइजेशन निकालना हो तो आप कैसे इसको कैलकुलेट करोगे? Now if the question is simple, question is calculate the shape. What will be the shape? What will be the geometry? तो आपको बता दिया है बॉन्ड पेयर लोन पेयर से आप ज्योमेट्री निकाल लीजिए. फॉर्चुनेटली बॉन्ड पेयर लोन पेयर के हेल्प से आपको हाइब्रिडाइजेशन नहीं निकल जाएगा. So let us see how can we calculate the hybridization with the help of your, you can say, the concept of bond pair and lone pair. How we can calculate? For example, carbon in methane. So the step 1 is the first step is, you can say the first step is calculate the total number of valence electron present in the molecule. आयन है तो आयन है, आयन है तो आयन. इफ देयर इज केटायन तो एक माइनस कर दोगे, एक पॉजिटिव चार्ज है, इफ देयर इज एन आयन वन ऐड कर दोगे. उसका भी एक आध एग्जांपल आपको बता दें. So this is the step 1. We have already discussed in online class that how we can calculate it. Anyway, let's do it. So if we have methane, you know carbon have valence electron 4. Carbon have valence electron 4 because carbon is 6. 6 means it is a system of 2 4, that is 1s2, 2s2, 2p2. So the valence electron is your 4. Electron present in your outermost cell. तो कार्बन का 4 वैलेंस इलेक्ट्रॉन हो गया. नाउ व्हाट इज द वैलेंस इलेक्ट्रॉन ऑफ हाइड्रोजन? 1. हाइड्रोजन का एटॉमिक नंबर 1 है, वही तो उसकी वैलेंस इलेक्ट्रॉन है, 1s1 है. But the number of hydrogen is 4. So 1 into 4. So total is your 8. Now second point is, the second point is find the number of bond pairs. ये मैंने आपको बता दिया है how we find the number of bond pair. Normally we calculate octet, but for hydrogen duplet. आपको याद होगा for hydrogen we count or we calculate duplets. कितने duplets हैं? Because duplet में ही वो स्टेबल हो जाएगा by attaining the configuration of noble gas, that is your helium. So here number of duplet for hydrogen. So number of bond pair we can write, that is in this case 8/2. Why 8/2 आप समझ गए, इसलिए मैंने स्ट्रिक्ट मार्क दे डाला. So it will be your 4. Third point, if any remainder left, कोई रिमाइंडर अगर बच गया, आप कहेंगे यहां नहीं रिमाइंडर था, ठीक है, नो प्रॉब्लम. इफ एनी रिमाइंडर लेफ्ट, then it will be your lone pair. Now in this case your remainder is 0. In this case your remainder is 0. It means your lone pair is 0. It means your lone pair is 0. Now the third means fourth point is the sum of bond pair plus lone pair. आप पढ़ चुके हो कि सम ऑफ बॉन्ड पेयर और लोन पेयर को हम लोग कलेक्टिवली कहते हैं इलेक्ट्रॉन पेयर. द सम ऑफ बॉन्ड पेयर प्लस लोन पेयर इज इक्वल टू योर इलेक्ट्रॉन पेयर्स. दिस सम इज योर इलेक्ट्रॉन पेयर्स. क्लियर? एंड next point, the number of electron pairs is equal to the number of hybrid orbitals formed. यानी जितना आपको इलेक्ट्रॉन पेयर हुआ, आप ये मान के चलिए कि उतना ही आपका हाइब्रिड ऑर्बिटल फॉर्म होगा आफ्टर हाइब्रिडाइजेशन. तो इन केस ऑफ योर मीथेन, व्हाट इज द नंबर ऑफ हाइब्रिड ऑर्बिटल्स? सो इन मीथेन you can say number of hybrid orbitals that is equal to 4. And if number of hybrid orbital is 4, then the hybridization is sp3. If it is 4, it means sp3. अब देखो कितना आसान है. If the number of hybrid orbital is 3, तो 3 किस में होगा भाई? sp2. If number of hybrid orbital form is 2, hybridization is sp. If the number of hybrid orbitals form is 5, it is sp3d. और 6 रहता तो sp3d2. For example, if we consider PCl5, अब उस 5 में से एक दो अगर हम छोड़ भी देंगे तो आप खुद कर लोगे. If we consider phosphorus in PCl5, now what is total number of valence electron? Total number of valence electron, phosphorus 5 plus chlorine is 7, so 7 into 5. Why we write 7 into 5? 7 into 5 हमने क्यों किया? क्योंकि 5 क्लोरीन है. So this will be your 40. Now what is number of bond pair? Number of bond pair means number of octet. 40 divided by 8, that is your 5. Any remainder? No. Remainder ZDR means 0. So you can say your lone pair is 0. Now lone pair. So what is sum of bond pair and lone pair? 5 plus 0 means it is 5. इसका मतलब कितने हाइब्रिड ऑर्बिटल्स फॉर्म हुए? It means you can write hybrid orbitals form. You can write this is your 5. So the hybridization is S, then we have P3, then we have D. Now let us consider the third example. Hybridization of, let us consider the third example. Hybridization of phosphorus in PCl3. Valence electron, total valence electron, phosphorus देखिए कितना है भाई? 5. Chlorine 7, 7 into 3. So 7 into 3, 21. 5 plus 21. Now it is 26. So what is number of bond pair? What is number of bond pair? 26 by 8. Can we write 3.25? No. Means your number of bond pair is 3. Number of bond pair is 3. यानी केवल हमने 24 इलेक्ट्रॉन लिया. Now what is remainder? You can say remainder electron रिमाइंडर इज इक्वल टू 2 इलेक्ट्रॉन्स। तो ये जो आपका 2 इलेक्ट्रॉन रिमाइंडर रह गया, इट मींस योर लोन पेयर इज इक्वल टू 1। So your bond pair is 3, but your lone pair is 1. Now what will be sum of bond pair and lone pair? So you can say sum of bond pair and lone pair, that is your 3 plus 1, it means it is 4. Now if it is 4, it means 4 orbitals are formed after hybridization। ये 4 कहने का मतलब हुआ कि हाइब्रिडाइजेशन के बाद कितने ऑर्बिटल बने हैं? हाइब्रिड ऑर्बिटल्स 4 बने हैं, 4 बने हैं। और अगर 4 बनते हैं देन योर हाइब्रिडाइजेशन इज सिंपली sp3। नाउ देयर में भी क्वेश्चन, यहाँ एक क्वेश्चन होगा कि सर TCl3 में sp3 है, देन व्हाई नॉट इट इज टेट्राहेड्रल? आपको आगे भी बताएंगे, आपको बता भी चुके हैं, इट इज ड्यू टू द प्रेजेंस ऑफ योर वन लोन पेयर। सो वन लोन पेयर इट इज नॉट टेट्राहेड्रल, इट इज योर पिरामिडल। अगर लोन पेयर नहीं होता, ये चारों बॉन्ड पेयर हो जाता, देन यू कैन से इट शुड बी टेट्राहेड्रल because due to sp3 hybridization. So even there is sp3 hybridization, but there is one lone pair, so this molecule is your pyramid. So I hope it is sufficient. You can calculate hybridization very easily. Thank you.